Welcome everyone. Thank you for taking time on a busy middle of the week day, and and thanks to Ian to actually, agreeing to talk to us with his experience in building the LLM and the RAG systems. He's based out of Canada, I think Toronto, right, Ian?
Yeah, just outside Toronto.
Outside Toronto. Okay, perfect. And I'm Kiran Adimathyam, and I'm the host at this point of time, for the DFW Emerging Tech Hub. And many of you have shown interest to join the group, and it's pretty consistently growing in number. And I welcome you all to this meetup. And we're going to have these kind of meetups in person and also online meetups every few weeks. I'm actually lining up a few speakers. Some of them are actually joining the call. Parag, welcome. And Murali, I think some of you guys I personally know. Thanks a lot for taking your time and joining this. So without much ado, I think we're 4 minutes into the call. We have I'll just quickly explain the format of this. We're going to have Ian speak about his experiences and what how machine learning models are going to evolve in the enterprises and in the upcoming future, and his experiences with while he was building the systems for his own clients. He's going to share that information and also some guidelines and principles that he had put together. He thinks that are the best ways to actually get these onboarded into the enterprises. So first, we'll let him finish through the presentation, and then the last 15 minutes we'll open up for Q&A. All right. So let's dive in. Floor is yours, Ian.
Okay, great. Thanks, Kiran. So I'm just going to share my screen, and then I'll do my quick introduction and so on.
Sure.
Hang on a sec. Let me know when that's... Oh, I see. They give us a nice little window nowadays. Zoom is slowly improving all the time.
Yep.
Okay, so as Kiran said, and as you guys saw in the invite, this is a general discussion about language models in tomorrow's enterprise, as I've titled this. I do want to give you a quick background on myself, in part because it conditions the kind of things I'm going to talk about today. So first of all, my background is very much in consulting in general rather than specifically and only technology. So I started as an Accenture technology architect. So I did go fairly deep into technology at the time, but that was 20 years ago. I had a long mid-career stage of working in strategy consulting and working in board governance consulting, and then in marketing and content marketing consulting before turning back to tech. So I came back to tech. Sorry, I'm going to stop every couple of minutes to let people in.
Sure.
I have to make sure I can see that too. So
sorry for the additional
no problem. Yeah, no, it'll probably kind of get me to stop rambling, which will be nice for all you guys. I returned to tech about 3 years ago, just got into cloud architecture and then gradually into data visualization, AI, a little bit of quantum computing, and finally kind of focused actually in the Salesforce space, focused on data engineering, data analytics, AI, and then recently, 6 months ago, language models and retrieval augmented generation. So this has been a work in progress for me. Kiran and I started talking partly because of a infographic that I'll show you halfway through this presentation, but also in the context of my views on where language models might go within an enterprise context, rather than specifically as they may evolve as technologies themselves. And so we thought it'd be good to do this kind of a webinar on that broader context, right? So I'm approaching this both as somebody who knows, a decent amount of, how to set these up and implement them and so on in an enterprise, but even more so from a business consulting point of view in terms of how enterprises look at this, how business value is created, and some of the trade-offs that you need to think about when you're taking this out of the lab and moving into real-world client work with it. So that's the context here. So there are going to be many points that I say where some of you are going to think to yourselves, oh, hey, that's not state of the art, or Ian probably didn't read this paper. You're probably right. I didn't read that paper yet, right? Like I've been fairly heads down working with clients for the last many months, and I'm going to miss a lot of specific points of technology. But hopefully this is useful from a broader context point of view. So that's to set that stage. Let me just let in somebody. Okay. Okay, so moving on from that, why are we talking about the enterprise? So what's so special about it, right? Why is this so different from, working in Jupyter notebooks and in lab environments and even in startups, for example, right? So enterprises are, of course, very different beasts. They're much larger, much more complex. And in terms of how this affects language model architecture or implementation, there are several points I want to make about this. So first of all, enterprises, because they're so large, they have both scale and cost constraints, right? If you have a language model that, they're all built to run on GPUs, and again, in the lab, you can fairly easily get a virtual machine with a GPU or two on it, and your model may run beautifully on that. You may discover that if you then go to an enterprise and say, okay, we need to scale this out across, our entire infrastructure, and we're going to need several of these models running in different divisions and so on. Suddenly saying every single one of them is going to need GPU machines may have an accountant suddenly saying, hey, those things cost a lot, and they're also a little bit hard to get at this kind of scale. So, that kind of push towards, can we run language models on CPUs? I'll talk in more detail about that in a little while, is driven by, this ain't a lab. This is now, full-scale enterprise, and scale and cost matters a lot. Likewise, project hurdles are completely different in an enterprise from an accounting or an economic point of view. Interest rates are different now, as you may have noticed, right? 2 years ago, everything was zero interest rate policy. It was very easy to get projects over the hurdle of how much return do we need to get from this project in order to say, yes, we're going to fund it. Now your projects need to have really clear returns over much tighter timeframes in order to get program managers to actually fund it, or senior executives to fund it. So that's another big change that has happened in the last couple of years. Large enterprises obviously have very big concerns about privacy, both their own data and the data of their consumers, their customers. Security, compliance with regulations, all these matter hugely. Predictability and reliability obviously matter a lot as well. So again, something that runs quite smoothly on a Jupyter notebook or on a small VM with a couple of scripts is not necessarily going to run as reliably when it's scaled up, put onto all sorts of different infrastructure, different OSs, et cetera. So having an awareness of those constraints and the need for that kind of bulletproof reliability, is a very different matter in terms of planning your project and planning the technology that you're going to be implementing. And finally, enterprises exist in this big complex world of having lots of consumers, lots of employees, all of them with, different value sets, different backgrounds, philosophies, expectations of both customer service, language that's going to be used by an enterprise when it addresses them, and different reactions that they're going to have to language models, whether it's a behind the scenes language model that's just returning results from a database, from a knowledge base, let's say, or even more so if it's a front of the house language model that's actually behind a chatbot, for example. And we all know of plenty of cases out there where companies have taken the wrong approach to that and kind of tripped over the third rail with that sort of thing. So that kind of complexity is very important to pay attention to. So what I'm going to do now is tell you about a couple of projects that I've been working on. They'll probably take about, I'd say, 10 minutes each to kind of talk through. Don't worry about the sketch on the right. I will happily zoom into it as I talk about it, because I know a lot of the fonts, the typefaces are kind of small. But one of these projects, this first one, is a actual live client project that is in production. So, went from concept all the way to final delivery. We're still working away on improving it. And the second one is more of a personal project where I'm just kind of experimenting with some technologies, and it'll make logical sense as to why I'm experimenting with those, given what I've been talking about here. So, excuse me. So both of these are useful to talk about from an enterprise point of view and from thinking about language models. So project one is for a manufacturing client. It's a client, kind of a mid-sized client that uses Salesforce quite heavily, especially Service Cloud. So that's the side of Salesforce where you, yep.
Can I say, can you put this in the slideshow mode just for the
Yeah, I'm just worried that I'm not being
okay. So
able to
to
zoom in.
zoom in. Got it.
But
Okay.
this might help anyway. Yeah. I'll drop out of it if I have to zoom in further.
Okay, sure.
You don't know, Kieran, if there's like a cool technique when you're doing PowerPoint for actually zooming in when you're in slideshow mode?
Yeah. I'm
Right
not
click.
aware of that. I
Oh,
think you
there
can
is a
by the
magnify
slide.
slide.
Yes. Yeah.
Oh, wait.
Yeah. There you go.
Hey, okay, we've solved it. We've done
Yep.
things at once. Okay, good. Thanks. Now how to there.
You found it. I was just reading through.
Excellent. Learn on the fly. Okay, yeah. So as I was saying, this client is a manufacturing client, mid-sized Salesforce user, especially Service Cloud. And their basic business case here is that their customer support reps are actually highly trained engineers because they sell IP-enabled equipment, which is quite sophisticated. It goes together in complicated architectures. And so when they get customer inquiries, essentially about either pre-sales or support inquiries, those are generally kind of complex and they need real engineers to solve them. And so there's a scaling issue for them because as they win more and more clients, they are not enjoying the sort of one-to-one linear scaling that they have to do with their support team because it's expensive to hire engineers, and they're getting harder to find, right? Especially in their neck of the woods with a particular skill set that they want. So the idea was Salesforce came along and said, well, we've got this new GPT offering where we hook Service Cloud into ChatGPT via an API. And that means that we can essentially allow the customer support rep or the support engineer to look at the customer email as it comes in, find the best knowledge article that explains it or responds to it, and then take that customer question and the knowledge article and automatically send it up to ChatGPT, and down comes an email response, a drafted email response, as you might expect. And so the customer was thrilled. They bought that SKU from Salesforce, and my team and I were the consultants helping them implement it. Implementing that was quite easy. The problem is that most customer questions are multi-part, so they're asking not just about one simple thing, but several things at the same time, or it's a complex question with several subparts to it. And so that was one of the problems. And the second problem was that their knowledge base, there was rarely a single article that covered that one question perfectly. What they would get is what they needed was, in fact, something that could go out and find the right partial answers across a whole bunch of different articles and bring those together. So so we looked into it, and I looked into it, and I found, there's this thing called RAG, retrieval augmented generation. This was 6 months ago, maybe 9 months ago now that I think of it. It's like kind of midsummer 2023. And we realized, hey, if we could build this extension and hook, bring in the customer questions, interrogate them against, bounce them off language models and so on, build a vector store and that sort of thing. So I'll take you through the solution now that I've kind of given you the business case for why they were even thinking about going beyond Salesforce. So we'll just kind of magnify the slide here. Okay, so hopefully this is more or less readable. I'm not going to go through this in intense detail, but over on the left, you have to imagine Salesforce is sitting over here. So in comes the customer email into Service Cloud. It immediately then sends off a change event because this new case has been created, and we grab that using AWS AppFlow. We bring it, we land that event in an S3 bucket, and that triggers a Lambda function. And we decided to do that, to use Lambda functions because I really wanted my partners in the Salesforce implementation firm to be able to easily maintain this. I didn't want virtual machines scattered all over the place, all of which needed to be patched and so on. So I've been using serverless as much as possible with this solution. And so this Lambda function runs, of course, it takes the customer email, and the first thing it does is it simply decomposes it, because we're assuming that it has this really complex question involved in it. Now, it might be a simple question, in which case the decomposition is just a single, the question kind of comes back to you as the same single question. But if it's a multi-part, 5-part question, back come 5 clearly broken out sub-questions. And we do that by just throwing that complex question against a relatively straightforward LLM. It's Titan Text G1 within the Amazon Bedrock infrastructure. And we get this question sequence out of it. And so, oh good, I can just move this around. So naturally, we then have to embed that, throw that against the vector store to do that classic retrieval augmented generation thing by bringing out the most relevant answers. Those embeddings, of course, are run off another LM, which in this case, again, is a AWS Bedrock offering, which is the Titan Embeddings LM. And we've got this vector store prepared. Now, first of all, to note, this is not a fancy technology. This vector store is just an Aurora Postgres database on AWS RDS, the service they offer for these kind of databases. It's got a PG vector extension, which is the column that you're going to use to store the extremely long vectors that you've gotten from embedding all this information. And we've brought in, or sorry, down here, we have scraped 2 knowledge sources to fill up this vector store. So we've scraped both their website and PDFs on their website, so both URLs and PDFs. This is just using LangChain libraries to do that scraping. And then we brought in via API all of their knowledge articles from Salesforce. So we've got both sets of knowledge poured into the vector store. Essentially all of the stuff they ever wrote down that could possibly answer a question, it's in this vector store. And as you all know, the RAG process works by bringing back these kind of n similar answers, depending on how you've set it up, how many similar answers you want. And again, depending on the algorithm you're using to do the similarity. But that comes back through a retriever, and then it comes back. Now it shows it here. I've simplified it. It shows it here going off to ChatGPT. What in fact it does is it comes back to Salesforce first, and it lands on that same case record that the customer support engineer is using, and it's brought back the answers. So even if we never then send it to ChatGPT, and that was the only thing we ever did, the advantage there is that we've given the support engineer a broken down list of answers with extracts, obviously, chunks, that they can use to then answer the customer question. And we're also including citations with links. So if the support engineer has a question about, I need to know more about this extract, maybe it's wrong, or maybe it's partial, I need to get to the root of this, they just click on that link and they go immediately to the website and the source of the extract, or they go immediately to the knowledge article within Salesforce. So even that stage is a huge win for their support engineers. But of course, we're then back in the Service Cloud environment. And so the support engineer can also just hit the button draft email and up it goes. So the context, which is the answers to the questions, goes up with the original question up into ChatGPT through the trust layer that Salesforce has built, and down comes a draft response, which has been based on multiple knowledge articles, all drawn from this originally decomposed question. So that's more or less the, so I'll zoom back out again here. That's the approach there. So we had to build a lot of, sorry for the folks, actually, I'll just let them in. Yeah, so sorry for anyone having to wait in the waiting room while I'm chatting. I'm pretty quick to catch everyone, but to welcome to the 2 folks that just came in. But this is not sufficient. I mean, there's definitely client demand. They're really thrilled with this so far. It is helping their support engineers. They can see an efficiency uplift. But we're now building out this front end because they do want to be able to, for example, change the list of articles that are going to get refreshed into the vector store. And they want control over how often does the vector store get refreshed and where are we going to refresh it from? Can we do that on demand and so on? So this is to the point about building out a full enterprise solution. You obviously need to know what you're doing with setting up vector stores, working with prompts, working with retrieval logic and all those pieces of the RAG and LM puzzle. But you also need, and I'll just zoom in on this part as well. You also need, to be authenticating, and you need to build APIs at the front end with very specific Lambda functions to go do very prosaic things like getting the list of articles in the vector store and presenting that on the front end of the client UI. So that's a whole other set of technologies that, you may have other teams to do it for you, but it still needs to be thought about in the architecture and in the project planning and so on. I don't want to overdwell on this one, so I'm just checking the time. So let's see. So we covered ongoing improvement. The final point I just want to make about this solution is really in defining the business values. So none of our conversations with the client involved words like transformative or AI revolutions or things like that. We kept this as prosaic and practical as possible. And this solution is really all about just improving the productivity of support engineers so that they do not have to hire 50 new engineers. We're boosting the productivity of the ones they already have. And the math is fairly straightforward. If you've got a big complicated question that you're answering and it's going to take you 10 minutes to write out that email, which is easily the case, and that's happening once an hour, but we're saving that because this system is creating an automated email for you with the right answers in it, and you don't have to type it out. You just have to quickly edit it for small details or a little bit of language change. That 10 minutes per hour across your user base of support engineers can be worth hundreds of thousands of dollars a year. And that math is very easy to show, and the client will find it very credible. So these kinds of business cases are the ones that's when enterprise is going to think about LM technology, right? It's like, how do you change my profit margin by the end of the year with this system that you're offering? How do you change my customer's experience with the system that you're offering? Are they getting faster service? Are the answers that they're getting more accurate? They don't have to back and forth with a customer, with the support rep 20 times just to get the idea across of what they're really asking. So these very tangible benefits are, again, the way enterprises think and what they're going to want to see out of LM solutions. All right, let's move to the next one. This one I'll spend less time on because it's sort of just reconfirming a lot of the things that we've been talking about. But in parallel with the client project that I've been doing, I began about a month ago, and I'm not making a ton of progress on this so far, just partial progress, because I do have many other projects on the go at the same time. But the idea here was just for me to set up within AWS a reasonable size VM. So this is now moving a bit away from the serverless principle, but in order to focus on CPUs, right? So my idea is I just personally want to understand what is it that you have to do to get a well-functioning language model to just run on a classic VM with a moderate amount of RAM. So this VM that I've set up has 32 gigs of RAM. So it's big if it's for your desktop, but if it's in the world of VMs, it's quite medium size. It does have 8 vCPUs, but it has no GPUs whatsoever. You can see, and tracking costs is part of this, right? Because the idea is like, can I come up with a solution that's just nice and feasible for a mid-sized company to be able to say, yeah, if this server, so this one costs $267 a month, that's a reasonable price for this kind of solution, and it's sustainable, and it's not going to break our bank. We're not going to worry about it if we have to order 10 of these, if we have multiple LMs around the organization. And we don't have to do, we don't have to wait in line to get GPUs. We don't have to worry about future GPU availability. So these are all the kind of benefits to it. But of course it also forces you as a technologist into, well, how is this going to work, right? I mean, certainly my first test with this, it would take, about a minute to just load into memory. And then of course it would take sometimes 2 or 3 minutes to just answer me. And this is without any quantization. I was just using, I think I still am using like a 7 billion parameter Mistral model. But of course, quantization is going to help a lot. So that's my next step. There are engines like Llama CPP, which I'm sure most of you know about, which also, boost the speed of these kind of LMs when they're running on hardware that otherwise would have a tough time with it. So this project is sort of my personal way to just make sure I understand all the technical details and the feasibility of running LMs efficiently and quickly with good performance, but on non-GPU hardware. And then, of course, I'm also doing RAG with it because I just want to see how far can I push this kind of shift of domain knowledge with choosing the right corpus of text to put in there. Let's see, is there anything else I want to talk about with this one?
Yeah, I would like to add a little bit
Yeah, Kieran,
one point over there, Ian.
please.
So you're doing the 7 billion parameter as a small LM, right? I think with the advent of or the release of Llama 3 a few days ago, maybe you want to take a look at it because the quantization is happening at pretty fast rate
Yeah,
on that model, and it has been actually sitting on the top of the charts across many tools that are actually maintaining the different parameters for LLMs. It's coming at the top and it's open source, so we
yeah.
can write out. And just this morning, I was trying on my local phone. There's a 5.3 model from Microsoft, which is 3 billion parameter model that can run on my iPhone, which is 13 Pro Max, with 4 gig, 6 gig RAM, I think. It's pretty decent.
Yeah.
I can load up the whole model with 1.2 gig, and then it can run and it can answer my questions pretty quick.
Yeah.
So just want to add that as a part of a small, language models, right? I mean, that's one of the stuff that you're pointing out. Maybe people who are listening to this can actually try it out.
Yeah, I think that's right. And thank you for that, those suggestions. I mean, it's kind of amusing, in fact, that I think if I were to give this webinar like 2 months from now, I would probably drop this slide because I bet the entire industry is like racing beyond what I'm working on here. And they'll
Yeah,
have all these very simple solutions for like, oh, geez, of course that's easy, a quick
every
little
day it's
model.
changing. Yeah,
Yeah,
every
yeah,
day it's changing. Yeah, so it's very hard. It's not nothing is like, you do it today, tomorrow you come back, you'll have something else better than that.
exactly. That's right. So yeah, so that's my second project. So the next area is just that kind of broad context and thinking. Oh, somebody was coming on and then I've lost them. Okay. Um, about where could this go? So this is the infographic that I shared about a month ago, I think, or maybe it was 2 months by now, on LinkedIn, with the promise that I would revisit it every month or two. So I'm probably due for another revisiting on this. And this, what you're looking at here, is just a kind of a quick um, vision of possibilities about how this might play out, right? And again, as Kieran is pointing out, the conversation already in the last 2 months has moved a lot in the industry towards assuming that there will be, not just large language models, but medium and small language models, and probably micro or nano language models. And I'm just making that up, but I will not be surprised if that's the case. So, but 2 months ago when I was pulling this together, still, the assumption was always, oh, of course, it's going to be a large language model. So the idea here is, we can think about over on the right, we have the classic vendor-provided API-based large language model, the ChatGPT 3.5 or 4. And it may be in the future that, of course, those things will stick around, but more and more enterprises will think, what's the particular use case for that alone? Do I really need to go outside my organization? Is there a particular need for the capabilities of ChatGPT 4? Maybe there is, but here's what they are. You're going to have to start being explicit about why are you leaving the enterprise and going to this outside vendor for their tool or their capabilities. What's special about that? And the answer could be either that we need incredibly high level language abilities, because we're doing a front-end chatbot and it just needs to speak perfectly and handle a really good general range of cases. And that's why we need GPT-4. Or the answer could simply be that we're a startup and we don't have time to sit down and figure out, a whole cluster of small language models here on-prem or in our cloud. So let's just quickly get up to speed by using an API out to the models that exist already, the big vendor models, and off we go. But over time, we're going to move away from them. So that's one approach. And then you can see in the middle of the infographic, both at sort of a layers point of view, that at the top, you might have like a router language model, as I've called it, but you could call it anything else. There's actually in the bottom, let me let someone in. In the bottom right, I'll magnify this. I just grabbed a slide because this is the idea of the router LM, except it's inside an LM, right? So again, many of you will know about Mixtral, right, which is the mixture of experts version of Mistral, but the mixture of experts concept being, can we build an LM itself with multiple modes or multiple capabilities, expert capabilities within it? And then as this diagram shows, a gating network is at the front end that is routing different messages to different experts within the LM in order to answer them most effectively. And so my thought about having the router LM was kind of more of an external version of that. And I think it comes from, I used to do telecoms way back in the day when I was at Accenture. So I still think a little bit in terms of routers and switches and so on as actual physical boxes. Excuse me. So this, I think this is where my thought came from, that there could be a customized LM that only sits there and figures out what is this question about and which LM behind it is most able to answer that. Another layer, and this was prompted by me working on that decomposer LLM within the client solution. This is the one that broke down complex customer questions into sub questions. But the general thought here is that the industry talks about is doing enhancement, right? On an initial prompt or initial question that comes in, you enhance it with an LLM or an LM in order to just make it better and more ready for other LMs down the chain in order to answer that more efficiently or to break it up and so on. Below that, of course, we have small LMs being these kind of the idea of being domain-tuned small language models. And below those, you have domain-specific knowledge stores. So again, here in spring 2024, not terribly groundbreaking stuff, but I'm just trying to grapple with how does all this sort of fit together. And what we see here as well, kind of in the middle, in terms of this this last small LM and this larger LLM, is the notion of just splitting up LMs by, again, what do you really want them to do, right? So this small LM we can see is doing something relatively simple, which is just summarizing and doing citations, essentially acting as a, let's say, a search engine, more or less, right? You don't need perfect language ability for that. So you probably don't really need a very large LM. You can get away with a smaller one, like a 7 billion parameter one. They do really quite well at those kind of tasks. But likewise, if you're going to set up a chatbot for external facing work and you need a lot of flexibility and a lot of high language capability, you may need a full scale LLM or at least a bigger one. Or a more finely tuned SLM, let's say. But you just need to think about there are different uses for all these different technological flavors, let's call it. Okay, so and I just very quickly down the right have just sort of notional names for things, like there could be all sorts of different roles, routers and enhancers and re-rankers. That's a famous one already. Classifiers, summarizers. Again, just keep thinking about what is the role for the LM that you're thinking about, and then pick the LM that works for that most efficiently and most cheaply and most reliably. Now, okay, so moving on to the next. So I'll have another 2 or 3 slides. I'll go relatively quickly through them. I think we've got about 7 minutes left before we get to Q&A. So this first one, is I'm starting to think about the LM question in terms of kind of like dimensions, right? Like extremes of one or the other, but different dimensions of this. So one dimension could be the sort of on one end is the general purpose, and on the other end is the specialized purpose. As we've been talking about already, right? If you have a need that's a highly general, requires flexibility, it's hard to define what's going to happen next or what the requests might be. That points to bigger LMs, that points to potentially using the ones that are out there, vendor provided, for example, or hosted, that your own enterprise would not be able to afford to host, but you need that kind of general purpose capability. You're going to bring that in by API. Likewise, at the other end of that dimension would be a highly specialized purpose. Well, number one, you're probably not going to find that out there in the wild. And number two, it's probably custom to your own business. And you're going to want to get the return on that investment from customizing an LM by actually owning it and hosting it and controlling it and fine-tuning it yourself and improving it over time. So the general to specialized dimension is one that you probably want to think about when you're planning solutions. Another one, of course, is that trade-off between quality versus cost and speed. And again, that's going to depend on the task that you want for it. Certain things are going to require extremely high quality output. It doesn't have to be necessarily the quality of the language itself, but it could be the quality of its reasoning, or the thoroughness of its answer, that sort of thing. So definitely be as precise as possible about what you mean by quality when you're using the word quality. But the other end of that spectrum being, cheaper, faster, more sustainable, easier to put on a local LM, doesn't require GPUs, things like that. So that's the trade-off on that dimension. Another dimension, of course, as we keep mentioning, is inward-facing versus outward-facing LMs. Even with Llama 3, as Karen was mentioning, I just caught something on a CBS News website about Facebook allowing Llama 3 to get into chat groups on Facebook, where people are selling goods to each other, for example. And here it was found offering goods that, of course, didn't exist and it didn't have the right to offer. And so even the most sophisticated, just came out last week kind of language models are still going to be making mistakes. And you have to think hard about, do we start there from an inward point of view, or do we start with an outward facing LM, or do we mitigate that risk by actually starting with inward facing LMs? And then as we gain an experience and understanding about things like guardrails and policies and risks and so on, we can then move to outward facing LMs. So that's another dimension to make trade-offs across. Another one, of course, is more of a technical one, which is, good old retrieval augmented generation versus fine tuning. I tend, my personal, just the way the business situations I've come across lend themselves to RAG more than to fine tuning. But of course, there are many cases where fine tuning is the right answer. So this is not meant to recommend one or the other, but simply to say you have to consider, which of those is the answer for your business, for your enterprise in that particular use case. Likewise, talent and skills. So this is like the classic buy versus build equation that all enterprises have to go through every time they're looking at a new technology, which is, if we are going to insource it and put it on our own servers and do our own fine tuning or build our own RAG system, what are the skills that our team is going to need? Are those skills going to be long-term sustainable? They're going to need to have Python and Llama Index for the next 10 years, or is some of this going to age out? Does our team already have those skills? Are they going to have to train up on them? Or is it just simpler and cheaper to just hook up the API and grab somebody else's timeshare and LM with a big vendor, because you just can't afford the time to train your team and so on. So that talent and skills question is an incredibly important one. Also is conditioned by the core competency of your business. You may be entirely focused on producing something that everybody else produces, but at the lowest possible cost, and in which case it may not be the case that you want to customize a bunch of LMs to do some very special things for your business, because you're in kind of a commodity space and you're really just trying to do fast operations. So hooking up via API is simplest and cheapest, and there it is. Or you may find that delivering something quite special and quite customized now justifies the spend on building a custom LM infrastructure, for example. Kieran already hinted at this in terms of the very small LMs. Obviously, we're seeing a huge trend towards smaller and smaller LMs, all the way down to, as we mentioned earlier, edge devices effectively. So LMs potentially appearing on phones with extremely small, parameter counts and quantization and so on. The point I would make very quickly, because this is a super easy slide, is simply if and when that future comes to pass, as an enterprise, as an IT manager, and as an architect, and so on, you are going to have proliferating LMs across the enterprise, and you need to keep track of them, keep them updated, keep them governed effectively, keep the data flowing to them correctly, register them all, et cetera. So you get an expanding MLOps challenge from the amazing trend that these get smaller and more capable all the time. So something very important to remember there. And I think this is our last slide. So just some principles to leave you with. First of all, LMs are, they're not general intelligences, as we know, even though some major vendors are really hoping they do become general intelligences at some point, if only they build a data center that will occupy all of California. So, until that happens, we do have to constantly think about what are their special abilities? What is an LM good at, essentially, right? And what it's really good at is operating on unstructured data, whether that's text or imagery, and doing so, for generation operations or summarization or classification operations, all those sorts of things, and doing it probabilistically. Again, as we know, these are really, as the joke kind of goes, these are really big autocomplete engines that just do it at such an extent that it creates this illusion of thinking effectively. But remembering that they're probabilistic engines, that there is always the possibility that they're going to come up with the wrong answer. Or a slight, almost the right answer, but slightly wrong, or 90% of the answer you were hoping for. That kind of probabilistic nature means that they're going to be very good for a bunch of things, but they're also going to be really bad for another bunch of things, and that we shouldn't constantly think of them as this magic solution for everything. There are different roles for probabilistic tools, and there's a role for deterministic tools, which of course is classical code. So remember that both of them play really nicely together across a highly complex environment, and you have to choose the right tools for each of those jobs. On that same point, in terms of accuracy, a good rule of thumb is, use them when good enough is good enough. So naturally, if you're, in a hospital and you're trying to diagnose cancer, they may have a role in doing that for sure, but of course you're then going to need a human final step to make sure that the absolute top level expertise was used to be sure of that, because you don't want people dying when somebody is when a machine is just doing a good enough job, but it's not really good enough. Likewise, there may be, and enterprises will think about this, so you may have these conversations. There may be liability issues around if a human was to do something and make a mistake. If they put in their best effort, that is often legally good enough, right? They followed policy, they put in their best effort, a tragedy happened, but they put in the right amount of trying, because we know humans are flawed. But if a language model does that, that might be a completely different kind of liability situation, because we have different expectations of machinery versus humans. So bear that in mind. This is an evolving area, and of course, I'm definitely not a lawyer, so that's a different conversation, possibly a different session to be had. Another thought is just, like I hinted before, starting with low risk and high reward scenarios. So the first case that I showed you of the manufacturing client that I built the RAG system for, very low risk. Nobody's going to be harmed if it comes up with dumb answers for a while. But as it gets better, as we build out the system and it starts producing really good answers, the reward is high because you're just making people more productive. And so that business case is easy, but you're not risking reputation because you're keeping it behind the scenes.
Yeah.
So,
Hey, sorry to interrupt. Just a quick time check.
Sure. Yeah.
Minutes over the time to let people ask questions, and there are like a bunch of questions already available.
Oh, good.
There's
Okay.
also
Yeah,
in
I
the
can
way.
stop here.
Yeah. If we can actually let people go through for these later things. I mean, I just want to give the time to all the attendees to ask questions. So let me go through what we have. Yes, I think Guna was asking. If there's somebody, I think Sri was asking. Yes, I will actually send out this recording once it's available. And also, can you see if anybody is in the waiting room? Ian,
Yeah, I just let in another person. Yeah.
Oh, okay. Yeah. There was Guna. I think he was pinging me. Okay, perfect. So I think there are like three more points that you didn't cover. I think you covered the low risk, high reward scenarios, but the
Yep.
last two, enabling the orchestration flow, you touched upon that a little bit, but we can follow up through the question. So let me read through the first one
Yeah.
we have here. Where is it? Chat. Okay, the first question comes from Parag. No, it's Krishna. So does the system put in human in the loop? So he's actually referring to the first scenario, meaning does generated email go to support first with the ability to refine further before sending to customer? I think he was referring to the use case one where you talked about Sales Cloud and the RAG implementation.
Yeah, that is definitely a human in the loop situation where the draft email appears on the Salesforce screen, having just come in from ChatGPT, and the support engineer is then able to edit it, add things to it, and so on, and then they send it, and then they hit send. So it definitely doesn't go out automatically.
Perfect. Okay, the next one we have is Parag is asking, how do you validate that ChatGPT gives a relevant and correct answer for the first use case?
Yeah, so right now it's all human validation. I have not wrapped my head around the many really attractive looking evaluation, like systematic evaluation tools that exist. And I think like Llama Index and LangChain offer them as well, and there are definitely some independent libraries for it too. Um, I do have my reservations that certainly a systematic way or a mathematical way of telling if an answer is high quality is going to be good at scale, but is going to have some potential risks in it. But anyway, we're doing human evaluation. So really just the support team is looking at tickets as they come in. When they see one that seems to have a silly answer or an irrelevant answer, they flag it, and then we just look into, can we improve that, or was that something we would expect the system to do? And I will say one of the big limiters is really just what's in the knowledge store, what's in the vector store effectively, because there are many new problems that come into a customer team. And if they have not created a knowledge article for that, then of course it's got nothing to go on, right? It's just going to walk and make something up. So getting the vector store constantly refreshed with new answers to new problems is actually a very important part of having a RAG pipeline that delivers some good value.
Yeah, so I mean, basically what you're saying is vector database is the one that provides the source to the right answers based on the documents that you feed in, and how often you keep it updated matters to how good the answers is or how latest the answers are, right?
Yeah.
Perfect. So now let's move on to the Parag. I think Krishna, I think you guys are getting the answers here. So perfect. Yeah, let me go through the other one. So Krishna says, regarding project 2, RAG over CPUs, what was the outcome of running the two quantized LLMs for articulation and embedding on single VM? Was the performance acceptable?
Yeah, as I mentioned, I am only partway into this. So I think I described my first attempts where the performance was abysmally bad. But then I did try, my next stage was, is it LLM Studio? I think Karen, I might have mentioned it to you at some point, but there's that app you can download, which then is connected to Hugging Face, and you can kind of bring down LLMs at whim. And I was just able to use that to kind of test on my own desktop, which also has 32 gigs of RAM. What am I expecting to see, right? Like it's a little bit more difficult when you're doing it on a VM and you're sort of working with the kind of like raw Unix and everything, and just trying to make sure, is this running the way I think? Have I forgotten something? But then you can just bring in the LM on LLM Studio and just run it immediately and just play with the different quantized levels. And I found that Mistral 7B, even when I crank the quantize level quite low, and so it's running quite well on my desktop, it's giving me good answers too. So I have hope that if I just quantize it up on the VM, it's actually going to give me pretty good performance, and I'll probably settle on that and then just build out the rest of it.
Wonderful. Yeah, to your point, right? LM Studio and there's Olama. Generally, I've been
Yeah.
using Olama locally for all my local implementations. And I use it for coding as my coding co-pilots. I mean, I don't pay for Copilot to, from GitHub. I just use these local tools, which are pretty good. I compare with not just one, pretty, other tools like Gemini. And there are many other tools of coding copilots that are available. So I'll do a session down the line, how to do better coding with using these tools, and
Oh, good.
yeah. So I have that in the pipeline, but I'm looking for speakers like you or anybody that is interested to actually share and share the knowledge that you have accrued and help the community across. It'll be always welcome. So let's move on to the next one. I think Parag, your question is for everybody. Maybe we can pick that up later regarding the GPU technology. I have some pointers on it. I'll talk about that later. The next one is Krishna asks, in your experience, did you find it if it is required to build prompts specific to LLM, Mistral Llama, in terms of improving the accuracy of the output? So
Yeah.
LLMs versus the prompts, are they the same across all the LLMs or are they different?
Yeah, that's a fascinating question. Because right in the middle of the project, so this was maybe 3 months ago, that first LLM I pointed to, this is the manufacturing client project. So the first LLM I pointed to is the decomposer LLM, right? Where you take the complex customer question and throw it against that, and you ask it, give me a list of all the sub questions that are in this question. And the first, I forget which LLM I was using at first, but what happened was when I first asked it that question, it would give me a really nice clean list. It would just start, and I told it, don't give me any introductory text, just give me the list, starting at number one and just run it down. Because what I wanted was, because I had then had to take that in Python code and in the Lambda function, and I had to parse that out, right, into 3 or 4 or 5 separate sub-questions, and then go do vector retrievals on those. So I didn't want introductory language. I didn't want variability. I wanted very low temperature response. And then randomly, after about a month, it suddenly started adding introductory language, right? And now my system wasn't working anymore because it was treating the introduction as one of the sub questions. And so then I went through a process just within AWS Bedrock, because I was trying to keep it within AWS, but they have a playground, obviously. And so I just started using, 5 or 6 different LLMs and throwing the prompts at them to try and see, do they respond differently to the same prompt? And then I would focus on one of them and try different prompts with it. And I think I ended up, first of all, they didn't differ very much. I would have expected them to differ quite a lot, but there wasn't that much. I couldn't find one that was appreciably better than the one I started with. And then secondly, the one I started with, I had to come up with some kind of a little hack to get around the problem. And I honestly forget what the hack was. But after that experience, I started referring to all these things as horses, right? Like in the sense that they're an animal that will do something useful for you, but they have their own attitude and they will sometimes mix it up for you, right? And this is the problem. One of the toughest engineering parts of this is when you're building a whole system, right? You're connecting these probabilistic animals that have attitudes to deterministic code, right? And the code is like, I expect exactly this. And the animal is like, I'll sometimes give you that, and I'll sometimes give you something different depending on my mood. And so you have to build the kind of robust code to do that interface that allows for that kind of playfulness, right? It's tricky.
Yeah, yeah. It all depends also on the alignment, how it was trained on, and it's more like
Yeah,
getting a wild horse rein properly so that you can start riding it.
yeah,
So you need to. There's some tricks and that people have been putting up on the internet,
yeah,
saying that, for example, they say like, oh, act as so and so, and then they start off the prompt. And also some people are talking about take a deep breath, right? I mean, as if you're talking to a human.
yeah,
And let's actually break this down step by step in making
right.
me understand the question. So there's like a couple of phrases where they have identified usage of these different phrases at different times
Yeah,
has actually improved upon the output of the LLMs. And again, I think to Krishna's point and yours also, right? It all depends on how you actually start conversing. It's more like how you conversed with your own LLM and how good information that you provide, the better the answer you can expect is what, in my experience, I have been getting through, right?
Yeah.
You just give a zero shot with no information at all, you might get an answer that may not be relevant to you. But if you give, a few shot, for example, if you say like, I want this answer to be like this, and then prompt it, you might get a better, answer coming back at you.
Right. Exactly.
Yep. Perfect. So we are almost like 2 minutes, before we close. Any more questions? Thanks, Parag, for the support. I will open it up for everyone else. Okay, perfect. I would like to thank Ian for actually coming on board and giving us and sharing us the knowledge that you have been accruing over a period or so. And a lot of effort has been going. I know you and I have been talking offline, Ian. So good luck with all your implementations, and we'll keep talking more.
Yeah, we will.
Yes. And thanks a lot, everyone, for joining this and keeping it very, making us to present to you guys. And we have like a lot more coming in the pipeline. I'm working with several people to bring in not only just the LLM part of it. Last time we did a ML Ops session. Swati, who is here on the call, she presented the ML Ops landscape, which was in person in Louisville, around Dallas area. So if you're in Dallas area, keep looking out for in-person sessions coming down the line every couple of weeks. I'll keep posting on Meetup. And if any one of you are interested to present anything from your end regarding emerging tech, it doesn't have to be AI specific. Any new infrastructural changes that you can bring to the table that can actually help with people across the board, please do so. All right. Thank you all. If there are no more questions, I think we can end the session here.
All right. Thank you, everyone.
Thank you all. So we can hang out for a few more minutes.
Yeah, I'll start figuring out how to hack back the host control.
Sure. I think people are dropping slowly.
I know I can stop the recording. You want me to do that?
Yep. Yeah, I can stop the recording.
Yeah.